Thanks for joining us. My name is Michael Shinneberry, and I'm with the museum's education department. In part 1 of Exploring the Universe with Sophia, we learned that SOFIA is the Stratospheric Observatory for Infrared Astronomy. Sophia operates in the stratosphere, above water vapor that keeps infrared radiation from space from reaching the ground. In September 2015, I was privileged to fly on board 2 Sophia missions, along with Jeff Killebrew, who is the science teacher at the New Mexico School for the Blind and Visually Impaired here in Alamogordo, New Mexico. One of the neat things NASA did with Sophia is the Airborne Astronomy Ambassadors Program. Ambassadors are selected as pairs of formal and informal educators who get to experience the excitement of modern astronomy and share it with students such as you. After taking an online astronomy course, Jeff and I spent an entire week in Palmdale, California. We began the mission here at the Armstrong Flight Research Center, named after Neil Armstrong, the first man on the moon. Armstrong Center is home to the Sophia Jet and its crew and engineers. Flights begin and end here during our winter, when nights are longer, and during the summer in Australia, when it is winter down under. Unlike space-based telescopes, Sophia's instruments can be changed for different scientific studies. Maintenance can also be done regularly. Past Sophia campaigns have included viewing the births and deaths of stars and solar system formations, studying planets, comets, and asteroids in our own solar system, as well as nebulas in other galaxies, and black holes at the centers of galaxies. Astronomers have studied eclipse-like events of Pluto, Saturn's moon Titan, and solar system bodies beyond Pluto. The Sophia Jet began life as a 747 SP passenger jet known as the Clipper Lindbergh. Does Lindbergh sound familiar? The Clipper was named after Charles Lindbergh, who in 1927 was the first aviator to fly non-stop New York to Paris. He was competing for the $25,000 Orteig Prize, offered up by New York hotel owner Raymond Orteig. Clipper Lindbergh was eventually decommissioned and rehabilitated with more powerful engines to lift a heavier payload, equipped with a special observatory compartment, and became Sophia. Lindbergh himself was once a passenger aboard the 747, and his grandson Eric christened it when it entered service as an airborne telescope. Many people make Sophia work, starting with mission director Charlie Kaminsky. His office is filled with flight maps of every mission he's flown. While in the air, his word is absolute authority. Charlie is privy to every conversation ongoing during the mission and is the one from whom to ask permission to move from one section of the aircraft to another. In his career, he has also spent time working in the cold of the Antarctic. Our flight crew for the missions included, at left, Manti Antimisaris, and at right, James Less, a test pilot who at one time was stationed here in Alamogordo at Holloman Air Force Base. Also aboard for the first of our 2 flights was Ivor Dawson, standing, who is the founder of the Traveling Space Museum. Seated in front of him is the actress Nichelle Nichols, who played Lieutenant Uhura in the original 1960s-era television show Star Trek. This is Andrew Hilton, an astronomer who regularly flies Sophia missions. He started out college education studying art, changed his major to astronomy, and joined the Sophia crew for an incredible career. Coral Clark, shown standing, wrangles the Airborne Astronomy Ambassadors throughout the week when they're in California. She made sure we arrived at all of our scheduled destinations. And for this mission, there were the educators. From left is Susan Altman, a science teacher in Georgia, April Whitt, an astronomer in Atlanta, Joe Dodds, a teacher in Idaho, and myself and Jeff. Many famous persons have flown aboard Sophia and left behind a memento of their time here. Maybe you can recognize the signatures and inscriptions of Apollo 13 astronaut Fred Hayes and Bill Nye the Science Guy. Every mission begins with a pre-flight briefing. Astronomers know exactly at what point in time and at what altitude they will be capturing images. Bad weather can quickly end a flight before it even begins. On the left is Nichelle Nichols as we strapped into our seats for takeoff. She holds a tribble, a recreation of a creature featured in the Star Trek episode The Trouble with Tribbles. Charlie Kaminsky made this tribble for her, and throughout our mission, tribbles kept mysteriously appearing around the airplane. Watch the Star Trek episode and you'll get a good idea of the humor in Charlie's practical joke. Also, as we were in our seats awaiting the start of the flight, Nichelle sang to us a song that she had performed in a Star Trek episode. Before turning to acting, she performed in the big band era with Duke Ellington and Lionel Hampton. About 4:30 the afternoon of a mission, Sophia lifts off the runway. Each flight lasts an average of 10 hours and covers 5,000 miles. We even had to bring passports in case of an emergency landing in Canada. The flight patterns for the 2 missions on which Jeff and I flew are shown here. The first, on the left, flew near the Arctic Circle. On Nichelle Nichols' mission, the pilot announced that we were flying over Vulcan, Canada, that is, not the home world of Star Trek's Mr. Spock. Once in flight and ready for observing, the door covering the telescope is open. Flights for actual viewing take place at night. To create the telescope housing, a solid bulkhead was built into the jet to separate the enclosure from the pressurized compartment where astronomers undertake viewing. When completed, the bulkhead tested for pressure stability at 1 million pounds per square inch. The housing was so well constructed that when the door is open for viewing, no air turbulence whatsoever is felt by astronomers and passengers elsewhere in the jet. The astronomers sit on the other side of the bulkhead. The rectangular equipment at front is one of many cameras that are interchangeable from mission to mission, depending on research goals. This is part of what makes Sophia so valuable. On a space-based telescope, changing out this equipment would be impossible. Here, the technology can be changed for a flight the very next day. An example of what Sophia can do is in these pictures of massive clouds of ionized hydrogen called H2 regions. Compare the rich detail produced by Sophia with images from the Spitzer Space Telescope and the very large array of radio telescopes in Socorro, New Mexico. This image shows W43, one of the most active regions of star formation in our inner galaxy. Educators aboard Sophia flights have their own dedicated console. From here, we viewed in real time everything that the astronomers were viewing. Jeff and I are pictured at the console during various points in our flight. Mine was taken about 2 in the morning. We communicated through the headphones and attached microphone with each other and listened to the astronomers as they viewed and made findings. Staying up throughout the night, it wasn't difficult considering the adrenaline coursing through us and a cup of caffeine from time to time. Educators kept up with flight and atmospheric status. The console data included altitude, interior and exterior temperatures, and whether or not the telescope door is open. This close-up of the screen, taken early in the morning, shows we are at 43,016 feet in altitude with an outside air temperature of minus 43 degrees Celsius. That's minus 45 degrees Fahrenheit. The interior was kept cool too because heat tends to damage sensitive equipment. While these 3 images on the console are actually the same target, different colored filters will bring out different features. Again, these are false color images that help see the invisible. On the right, you see Nichelle at her console later in the evening. She was not along for the flight because she'd once played a character in a popular science fiction television show. This was a working trip for her. She was online answering questions from students who had signed onto a webinar. And this was not her first Sophia flight either. She has long been a proponent of the program and of science in schools in general. Educators are invited to bring along their own experiments to undertake during the flights. April and Susan wanted to know how large you could blow up a balloon before it burst on the ground versus once in the air inside the pressurized airplane. They found that even though pressurized, the balloon burst in flight earlier than it did on the ground. Spending time in the cockpit with the pilots offers a view of the night sky and land below that is unequaled. Being so far north on the North American continent means the opportunity to view one of nature's most spectacular light shows, auroras. Jeff took this photograph, and you'll notice out through the windshield you can see an aurora. As Airborne Astronomy Ambassadors, Jeff and I are tasked with the awesome responsibility of taking the Sophia mission to the public. But while on board, Jeff took the opportunity to give a Braille lesson to Nichelle. Without a doubt, he probably now holds the record for teaching Braille at the highest altitude ever, this one in the stratosphere. Now, remember these two images of Orion from the first episode? The one on the left is Orion as seen with the naked eye. The one on the right is Orion captured in infrared light. Once the mission was over, Jeff, as a teacher at the New Mexico School for the Blind and Visually Impaired, had to create a way to teach astronomy to students with limited or no vision. He did that by creating Braille images of both of these images. And here they are. For the first time in history, sight-impaired students can now feel how an image in the night sky actually appears. The dots make up the picture. The more concentrated and taller the dots, the more intense the infrared activity, as you see in the Braille image. Eventually, we work our way home in some well-earned rest. But, like Starship Enterprise, the voyage continues. It has been chronicled on various websites, including NASA, Space.com, and even Star Trek. You can read more about the program on these sites, as well as on the Sophia Science Center website. Thank you for watching this presentation, Exploring the Universe with Sophia. Please contact either Jeff or me if we can be of further assistance.